All right, next up, the man who needs no introduction, the founder of FreeSwitch and SignalWire, Anthony Minessale. Big round of applause.
Thank you. Too kind. So thanks for coming. This is our 15th ClueCon. I'm not sure how many of you guys have been here different amounts of times, but let's just get a show of hands of who is new. How many is this your first ClueCon? Great. I hope we take care of you. Everyone around here in these Clue Crew shirts are happy to help you if you need anything or want anything that'll help you out with your stay. So we really appreciate your attendance. Without you guys, there's no point in doing any of this. So thank you very much. So I'd just like to give you a little bit of an overview on some of what we've had to go through over these 15 years in this pioneering effort to bring software-defined telecom to the next level. So we started out, this is what it looked like to use the internet to communicate when I first started working on this stuff. The most exciting app was Vocaltech internet phone. I had the dial-up modem, and if I was lucky, I could sort of tell I was talking to somebody, but it was pretty cool. It was like, you know, kind of ironic. I used my modem to dial up to get on the internet to have a less quality conversation with someone just to prove you could do it, but you know, that's the kind of stuff that attracted me to this in the first place, and it takes kind of a special type of personality. You know, engineers they're driven a lot by OCD and obsession. So, but since that didn't work very well, I mostly use this to communicate. Unix talk, like that was my favorite tool for a really long time. You know, you have to both be on the same machine, or sometimes if you open it up to the internet, you know, mine getting hacked, you know, you can remotely communicate with somebody in a text terminal, you know. And I've spent most of my career, you know, working in terminals, still do. A lot of us still do in FreeSwitch and the development team. Pretty much all of FreeSwitch was written in GNU Emacs, like straight from a VT100. So this was home to us in the beginning. So what started to happen, though, I don't remember the exact year, but suddenly, like, some hardware solutions popped up. I don't know if anybody remembers this thing. This was like an innovation that you could stick in the back of your PC, and then it kind of gave you a dial tone out the back. You could plug the phone into it, and the software would take you, you know, allow you to call into the internet and do a bunch of stuff. And that's what really started to spark my attention into telecom. The idea that you could do something like that always fascinated me, but it was like, okay, there's this complex hardware in the back of my PC lets me make one call sometimes. Like, it didn't work very well on the software end. I remember having to like tinker with this thing for hours. Probably half of my skill came from just getting this thing to work. And I spent a lot of time working on this stuff, and you know, I had other reasons to do it. I used to work in a company that did tech support, and we did it over the phone, and we had a high volume of calls, and we wanted to figure out how to like make that more cost effective. And this wasn't going to help because it's like one phone on the back of a regular PC. So we started looking at how can we do this at scale. And then we met this thing. I don't know if anyone knows what this is. This is a TNT Max. We used to love this thing. Basically plug a DS3 circuit in the back of it, and it spits out T1s. You have to have it racked in the data center somewhere with an expensive contract with the telco. We discovered these things. And we had a lot of fun with them, but it was still super awkward to pull anything off. You know, so we had this. We'd run into weird problems, like the timing on the T1 circuit wouldn't work, and you call and they don't believe you, and it takes like 6 months to get them to fix it, and all your calls drop for no reason, even though everything's perfect on your side, and they oversubscribe it. You know, you have this. You're supposed to have a DS3, but they don't. They have a T1 on the other side of it, and they don't tell you. So then one day, Current Affair has a poll, is Michael Jackson guilty, yes or no? And they bought phone numbers from us, and the whole thing lit up. And then they got mad at us for using half of what we were paying for in the first place. Those kinds of things were happening a lot. That was a pretty memorable one for us. So then came the era of the orange Kool-Aid. And I used to drink a lot of this. It was very good. I discovered Asterisk. I'm like, this is so cool. I love doing open source software in the first place, and now I can make whatever I want out of this toolkit. And there's a few other ones out there at the same time, and I evaluate all these. I used Asterisk a lot, became a committer. I had commit access back when it used CVS still. OpenH223 guys are my heroes. You know, they pioneered a whole lot of stuff. And I worked with kind of all these guys. You know, OpenSir is the grandfather of Camilio and OpenSIPs. So this is kind of the state of affairs at one point. Like, wow, there's like actual software out there that I can just build my own telecom company with. Like, all my problems are solved. And then I started realizing that they weren't, because there's lots of problems I'd have to deal with. So, you know, I built my solution the way I thought it would be cool, and being super innovative, and then all of a sudden it didn't work. You know, I'm like, why? And can't really tell. And I didn't know a lot about debugging that long ago, so I started learning really quickly. I was introduced to the GNU debugger, and what is a deadlock, and how do I restart my software every day. And so it was even worse than when I used the hardware. It's like, oh, I remember these problems, only now it's my fault. You know, so I spent a lot of time working on that. And the real problem was that we were trying to shoehorn some of these software into things that they weren't really meant for. Like, those days, the whole point of Asterisk was to terminate a T1 line into a physical hardware card in the back of the computer, kind of just like the QuickNet card, but only with more channels, and then have some phones connected to it and make a cute little PBX out of a PC. And then we were like, let's make an ISP out of that. You know, and there's like dumping traffic through it, trying to make a call center. It really wasn't meant to do any of those things. And we were being sort of, I would say, even abusive, you know, trying to shoehorn stuff like Asterisk into solving these problems they weren't meant for. And it was starting to kind of cause a negative impact probably on how the design works, you know, working against the grain of how it was designed. And, you know, one day I really just couldn't take it anymore. After like really staying up all night, like 3 days in a row trying to solve a problem. And I was just driven to try and figure out, like, what am I supposed to do about this? Because there's the stuff I really want. I thought I already found it, but it wasn't quite designed to do what I wanted. So I decided, you know, what's the worst that could happen? I'll just start typing in an empty file. I'm sure I can just make my own software switch. It's not that hard, right? And, you know, spent an entire year doing that. And right after that, we actually pulled it off. At least something that looked like software that could make a telephone call and kind of looked and felt like what I wanted. And that's where we got the first FreeSwitch from. And this is a real screen cap of what our website looked like in 2006. I don't know if anyone remembers this. Let me know if you've ever seen this for real on the internet back in the old days. So, yeah, a few of you. This is a pretty funny, memorable moment for us. We had this design goal. It was really around, there's a whole bunch of cool different things in the world that already work, and we want to try and minimize how many of them that we reproduce for no reason. That's one of our first goals, was make stuff that doesn't exist and then use the stuff that does, so that we have more time to work on the stuff that doesn't exist. So we put a lot of open source other libraries to work. And we had this modular architecture. So basically the plan of what it looks like, oh wait, no, that's the Death Star. This is FreeSwitch. Not entirely different. we built a core that was solid. The idea was put all the evil inside of somewhere where no one can touch it. We almost called it Pandora for that reason. That was one of the working titles before we came up with FreeSwitch. The idea was take all the complexity and then make it available through APIs to modules. So, you know, in the beginning we had, I don't know, like 3, 4 modules, and like, that's enough, right? You know, we look today, there's like 35 of them. We're probably working on getting rid of some of them more than adding them, because there's so many. Like, we have one that just makes the ASCII art train drive across the screen. I don't think we really need that one anymore. I'm out of ClueCon. I don't know if anyone's ever loaded that one before. It's a little commercial for ClueCon that drives by on the screen. Yeah, but you know, the most important ones were the protocols, the codecs. There were so many codecs at the time, and no other software was really focusing on like leveraging newer high frequency and high quality codecs. So we put a lot of effort into, if it was an open source codec, we had a module for it. And we had so many of them, you know, and the idea is that we could transcode between them, and not just transcode but also resample on the fly, because, you know, once we open that can of worms, you have like 8 kilohertz wants to talk to 48. We want to have a conference call with 8 kilohertz, and another one's 48, another one's 16. Or you have like, how do you record the call when those two are bridged to each other? Which one of the formats wins when you're trying to mux the channels? All these kinds of things that we've been digging into forever, you know, like. But that's what we wanted. We wanted to find like what is still not possible, so that we can make it easier. Somewhere in the middle of the lifetime of FreeSwitch, I don't know if anyone remembers the coup d'etat. Any of you remember this? This is like one of the first commercial products that employed FreeSwitch. I think it was late 2000s. We were pretty proud of it. You know, building that through the open source FreeSwitch, we were able to harden the stack, and a lot of others benefited from it that were consumers of our open source project. And we were able to kind of, you know, take a single machine and make it as powerful as possible, you know, and make a way to, you know, make it easy to digest, because FreeSwitch isn't exactly simple to understand when you first look at it. It's sort of like the way I feel when I look at 3D Studio or Photoshop. I can imagine there's like 1,000 parameters you can set, and you know, we tried to make it so some of that was easier. And it was a really good first attempt, and I'm happy that we did that. It gave us a lot of insight. We spent a lot of time working on that. We got to the point when Barracuda went public, we decided to figure out what we could do next. And this is around the era when this thing showed up. I'm sure you all know what this is. We're going to be talking about this later. But WebRTC was a pretty big motivator for RTC in general. And that was a really big challenge for us. You know, being like who we are, we're always trying to take things to the next level. So we're like, yeah, WebRTC sounds cool. Let's see what we can do. And then we had to do all these things, you know, like hand code our own WebRTC stack, because we already had most of our media engine, and we couldn't just like use a different one. We had so many functions and stuff that everyone depends on. So we had to figure out how can we simultaneously negotiate WebRTC and legacy SIP and those kinds of things. You know, so there's a big challenge of like finding the line where that makes sense, and also not just doing it exactly by the spec, because you know, after making internet protocols for 15 years, you know, I've started to learn like there's the spec and then there's the way that it actually works, and you have to find that line. Sometimes you can't always, like, you know, there's a joke that if 2 devices implemented the SIP spec to the letter, they probably couldn't communicate with each other. So, you know, that kind of thing has been going on in most protocols. You know, WebRTC is new still, and there's a lot of experimentation. And we got the guy in the audience, and I offended him, I'm sorry. We used to want to bring you here and beat you up, so we've come a long way. When we first started, we were like, who's the guy that made this? No, but now we're happy about it. We put all our effort into it and worked together, and yep, we'll be hearing more about the future of that stuff later. I don't want to give like everybody's talk for them, so I'm going to try and keep a brief overview of what's to come, since this is the beginning. So just make sure you stay tuned to the schedule. There's lots of great talks. Yeah, we made our own protocol, so that was cool. WebRTC makes you, so it wasn't our idea. Like, wait, there's no signaling with this? Okay, fine, we'll make one. And then the spec changes a lot. I mean, that's because we're not sure what works yet, so we just try stuff. Like, let's try this strategy to solve one problem or another, and then it doesn't work, so then you try another one. But for us, it's like normal. Oh, Chrome doesn't work again this morning. I guess I have to change the code. But not everybody wants that lifestyle. I think a lot of developers are just hoping to build what they want to build and have some kind of protection against that. We try our best to see if we can shim our way in front of that. And we're going to be talking about WebRTC today. You can come 4:15. There's a roundtable. A bunch of us will be making fun of WebRTC and pointing out what's new and what we're going to do next with it and that kind of stuff. So we've hit this era where, we built the product. We moved on and implemented the latest and greatest way to communicate inside of FreeSwitch. And our community was growing, and there was common themes were forming. Like, a lot of people are trying to do scalability. Like, I've managed to make a really good product that fits in one computer, and then, like, I guess I can make two computers if I want, but then they don't work together. And we have all these common problems, like, what do I do? In the old days, when we started FreeSwitch, we had it good, because back then, like, if asterisk is a PBX, and if you tried to pump calls into it, you could blow it up a couple hundred calls. And next thing, 2 years into FreeSwitch, they're complaining, I can only do 2,000 calls. So we had kind of like a buffer where we were able to, people were happy with what the difference was to put into one box. And someone round robined with a SIP proxy or something that would last pretty long. They're able to do, 1/10 the amount of hardware. So, but somewhere came along that we traded up. Like, now everybody's looking for even more. They're like, I want to have like some kind of amazing cloud architecture where you can just scale automatically, and can I just turn on FreeSwitch and it magically does that by itself? And we haven't been able to really do that. That was one of the problems that we keep seeing happening over and over again, especially now that there's VMs everywhere. We had to adapt FreeSwitch to run there. A lot of VMs cheat on the way the hardware functions. They have like simulated versions of things that we would count on in the motherboard in the old days, like the timer and stuff. There's software version. You need accuracy for RTP, so it takes a lot of work to try and deal with a software-only synchronized timer, and everyone wants to have 2,000 calls at once. So we pushed into that. We spent a lot of time figuring out, what are we going to do next. We went and visited Enterprise Connect. You guys ever been to that? Pretty big, giant conference. I went there, and for fun, I just looked like, who here is using FreeSwitch? And I found this is just like the short list. This is just the ones that paid money to be part of Enterprise Connect. So it was like, okay, we have a lot of people really looking for innovation from us. And, we started out with people doing hobbyist stuff, and then all of a sudden we have, like real companies depending on us. We have a lot of customers that are looking for things that go beyond just ordinary software stack. It's crazy that we've been doing this for 15 years. The very first ClueCon, that we didn't have FreeSwitch yet, but all the people that helped me to write it by influencing me and having conversations were here. And by the second ClueCon, we had the first presentation on FreeSwitch, which took me 2 hours, which I hope I don't do again, because you guys probably want a break. I'm trying to be a little more terse than I was back then. I actually went through every single module and how all the code worked. I don't know if anyone even wanted to know all that stuff, but we've come to a point where VoIP is actually making a big difference. It used to be something you would kind of just hide from everybody. You know, like the cable company uses VoIP, but then they put an ATA and tell you that it's just normal phone service because they don't want to deal with customers having to understand what the idea is of using the internet to communicate. You know, you have like a lot more bandwidth now too. Like I was so excited when I got an ISDN line at my house because I could have 128 kilobits. You know, and now we're like complaining when I only got 13 megabits on my phone while I'm at the beach. You know, like we've really come a long way. And we're like, there's a lot of stuff that we want to be able to do, but there's a lot more that we have to work on in order to get there. You know, all these developers that are cropping up, you know, we're actually starting to consider it more into our education process. So we have new developers that are learning simpler to work frameworks, which I'm jealous of. Like I was a web developer when I started, and I used to have to write CGIs that loaded the page every time, and you know, these kind of try and make it seem like it was really cool, but it was like a lot of work. And write programs on the server side that wrote programs that would run once they hit the browser, and all this crazy stuff we have to do. Just animations that were actually like a C program that had to like spit the pictures over the line. You know, like now everyone's got these magical frameworks that they're just like 2 lines of code and they have their entire app written. And you know, I think we need to do that with telecom also. And there's so many things that FreeSwitch by itself doesn't really solve, because FreeSwitch is an engine, and almost anyone that's going to use it commercially is faced with all the same problems. Like, how do I store users, and how do I scale that across multiple systems, and how do I keep track of, how do I have voicemail for 10 million users? You know, we have Comcast has been working on that problem for 5 years. Like, how can they make IP out of, take an IP solution that solves the crazy amount of hardware it takes just to have voicemail for 20 million customers? So, you know, I think this is a time when we started to realize that the regular audience in the world, you know, the mainstream audience, can probably handle understanding what IP communications are now. So instead of trying to trick them, which we've kind of been doing for a really long time, that we should start actually being proud of it. So that's why we started SignalWire. I think if anyone was here last year, we were just forming the company, and basically we're the first to know. We started, you know, in 2018, and put a bunch of the engineers together that not only help make FreeSwitch, but a bunch of some of the other best products you've ever used out in the IP world right now. And an overview of what we're trying to do with SignalWire is to make a company that can actually implement this complex scaling once in a way that everyone can share, just like we took regular FreeSwitch from a world where you couldn't even use VoIP and made it a solution that you could. But now, like, how do we do that so that all the people on the entire planet at once can do that? Because, you know, once you fill up one machine, you start getting kind of bogged down on how you're going to keep going. And SignalWire now is also the primary sponsor of FreeSwitch project and this conference, which is amazing because now we can bring all of our people together, and we can do things with FreeSwitch more than like the original 3 or 4 guys could. You know, for a while, FreeSwitch was only 3 people for many, many, many years. We would just work nonstop, and there were some things we had to overlook because of that, because 3 people can't do everything. So we would kind of do the best we could to navigate the triage of all the problems we had in front of us. So, you know, now we actually have a supporting entity that can make sure that we start doing some of the stuff that we always wished we could with when we had less resources. SignalWire is also a really great place to work. It's a fully distributed place. The workplace is the internet. We speak over video conferences, and if anybody out there is looking for a challenge, like a really big challenge, you're crazy to take this offer, but, you know, come and visit us, and we might bring you into our team, and you'll never escape, but it'll be great. But the good thing is, a bunch of people already did take that blue pill, and they're pretty much the best developers that I could find, you know, over all my years of working in FreeSwitch. Like, anyone who was available that I wouldn't choose different if I had it all over again. So these guys are amazing, and they're great to work with. And what we're planning on doing with this is trying to get the same kind of solution we did when we made FreeSwitch. We wanted to find what's the hard thing and make it easy for everybody else. But now we're at a new scale, because we're not just trying to do it for all you guys who are seasoned developers. We want to do it for your customers too, or other people who don't necessarily want to know how to go in a GNU debugger or deal with all these horrible things that I was describing before. So one of our big goals is to get out of the CPAST. You know, like somehow analyst jargon has started to make this the AS family of products, and you know, we don't want to be that. We don't like buzzwords. That's one of our goals. You know, we just want to make it obvious what we're doing, and we want to take some of these things, cut them into pieces, and make them digestible at any level. So our goal is to continue and foster the open source FreeSwitch, which we've done forever. So anyone that likes to use that, it's still going to be there, and it's going to be great. It's still fun to work on. I get a little less time to do it than I did, but now I have amazing people helping me with it, which is a trade-off that's great. And we have a FreeSwitch roundtable. I think it's tomorrow. So there's going to be a lot of stuff that you'll learn from that. All of us will be up here. You can ask us questions, and you'll get some more details on what's coming. And I'll kind of give you just a little bit of a taste. We'll just have a few brief announcements to make, and then I'll give you time to get some refreshments or whatever, so you can get ready for the conference. Got a lot of talks coming up. So the first big announcement is that FreeSwitch 110 is now released, and it's available. So anybody who uses FreeSwitch, we pulled it off. You know, last year I was telling you it takes us 2 years to make a release. So we only took 1, because now we actually have a lot of people working on it. So there's already a payoff from that. And the roundtable was right after Dangerous Demo, so you'll all be here for that anyway. So make sure you come to that too. And Mr. Bodie here in the front row, if he hasn't already tried to get you to sign up, like, he really likes it when you sign up for his Dangerous Demos. He wants to see you come up and look like a fool on the stage like I am now, but he lives for that. So make him happy. Come up and make something cool. In fact, we still have that SignalWire challenge going on that we started during the hackathon. So on Thursday also, you can, if you sign up and try out some of our preliminary APIs we've released, you could make something out of it and win some prizes, including a PS4 and an iPad. And we like to get the feedback while you're here, because you have all the guys. You report a bug, you can just walk up to them and tell them. So it's kind of cool. And just an overview of what's new in FreeSwitch. Well, we have much better release cycle, as I just said. It was much faster than the last one. We have a new unit test framework, which is something we always wanted, but it was like, who's going to make that? Because we were too busy writing all the code and fixing stuff nonstop. So, you know, now we've actually been able to expand the resources in that. Now we have a unit test framework. We have a new database abstraction layer. We sort of already did, but it was hard-coded into the core, but now it's expanded, so you can add more modules to use databases that we haven't supported in the past. I think we had built-in Postgres. You know, now that's just a module type you can load and make your own database stuff. We have packages for a bunch of new platforms, including Raspberry Pi and CentOS, which is something we haven't had in a long time. And we have native integration with SignalWire. You know, lucky for us, since we create both things, we were able to find great ways to combine them. And there's a module you can load into FreeSwitch, and if you want to use SignalWire for telco, you can just automatically configure it. You go into the UI in SignalWire, you can set it up, and it'll just magically create a SIP trunk for you and dump all your calls, so you can, you know, terminate in FreeSwitch and play around still. And also, if you want to, you can keep your eye on that, and we have a whole bunch of stuff planned for that, including some ideas like maybe managing your FreeSwitch machines. You know, you're effectively adding them to our global network when you load the module. So we have some ideas that maybe we can make ways for you to push some changes down to the servers and stuff and manage them all from central location. So we can chat about that in the SignalWire Lounge, where we have a bunch of beer and stuff tonight. So anyone that likes to celebrate stuff can come to there. And then we have one last announcement. This is a pretty big one. We've been working really hard on this, and we pulled off raising money for SignalWire. So SignalWire is now a venture-funded company. That's great news. We're going to put that to work by, trying to figure out how to take telecom and demystify it even further, and take all the voodoo that we've learned and all the pain that we've suffered and try and turn it into 1 or 2 mouse clicks for everybody else. So that's kind of our mission. And the Gigabit receptions tonight, in fact, come celebrate with us. And thank you all for putting up with me. That's all I have. If you have any questions, let me know. I'll stay up here a minute. But thank you so much for coming to ClueCon and for supporting us.
All right, what questions do we have for Anthony?
It's okay, I never usually have questions. I'm so thorough with my explanations that nobody needs to ask any questions.
Sometimes it just takes people a moment. You see, they got to they were so enthralled with your talk that that they have to percolate their questions.
Oh,
we have a question over here in the front.
Giovanni wants to know, how does it feel to raise $11 million? Well, it feels like a lot of work that I have to do. Because it's not really we didn't make $11 million. We raised $11 million that we have to turn into $1 billion. So we're going to get to work on that. We'll have a much better party if that happens. So stay tuned. We're going to try.
Do you have any?
Thank you.
We have a question over here in the gray shirt. Just yell it out. The question was, can you describe problems that happen when running FreeSwitch on Docker?
Yes, I'll do it only slightly because my CTO, Evan McGee, is going to be talking about that later, and I don't want to ruin his entire speech. He'll be really pissed. But yes, there are some challenges with that because there's a lot of different things with networking that you have to accomplish. The IP network inside of a Docker, it's almost kind of like running through double NAT in order to do it right. And we've wrestled with a bunch of that stuff. Luckily for us, Evan is a guru at that kind of thing. This is a great addition to our team. Virtualization in general is really cool. The first time we tried running FreeSwitch on VMware or something, we were all excited by it until it would freeze for 5 seconds at a time. For a while, we had a pretty cool thing where you could migrate. I think it's still in there. I don't know if it works anymore, but we had a lot of discipline into how we implemented things in the code because when you migrate a virtual server, you basically suspend it and copy the data and load it again. Now, sometimes things you don't think about come into play, like if you're trying to wait for time to pass. You can do things that are sleep techniques that take advantage of surroundings in the machine. And if suddenly the machine is not the same machine anymore, the clock might be a different time on the other one and stuff, and now was supposed to sleep for 5 seconds is going to sleep for a week. So we run into crazy stuff like that. So you had to be careful about how we did things that you would just take for granted. Oh, we can't sleep the normal way. We have to what if the server changes and the time is all different? And also the clock for getting feedback for when to time out on RTP packets was super challenging because we used to do, it's similar to what we used to do in old days on Apples. If we wanted to sleep, we would do a for loop because the computer was so horrible that just doing x equals 0, x is less than 1,000, x plus plus was how you slept for 1 second. So we would do kind of tricks like that with the timer where we would just micro sleep. a certain amount of time to let 1 millisecond go by. And we ended up implementing like 20 different ways to do that over the history of FreeSwitch. And someday, I forgot when, they invented this great thing called the timer FD in the kernel, which is a great accomplishment for that, because it's basically like a device that you can open a socket to, and it gives you reliable timing. So even if you're late, the next one will be less to try and make up for it all for you. So it's pretty cool. You just put it at the top of your for loop or whatever, and if you take too long, the next one will catch up by just not taking the same amount of time. It realizes that you're late, so it'll try and catch up by taking some of the time off. So that made things better, especially in the virtual world. Although we still run into trouble if that system is implemented virtually. It's still probably not work right, because sometimes they emulate stuff in the VMs. So yeah, all those things are pretty hard. I think we've got them under control at the moment, but I have faith that someone will find a way to mess it up for us again, and then we'll be back to the drawing board on it. But for now, we have things working great with that kind of stuff, and we can hear more about that from Evan. Anybody else?
I have a question for you. So you spent a lot of time out in California raising the money. Do you have any Silicon Valley style sitcom stories from your experience out there?
Yes, but I'm not going to tell them on the stage. My investor's in the audience, guys. But what I do have is, did you guys see Cards Against Technology, our game that we invented? We're going to play that tonight. We have an expansion pack for ClueCon, so if you've been to ClueCon a lot, there's some like inside joke versions of ClueCon. And by the way, if you see Abby in the audience over there, she made that entire thing by herself. She created all the cards in the box and ordered everything. It was an idea that we had and no one would execute until she came along. So thank her when you see her if you like it. And we have a Silicon Valley expansion deck, which is full of those kinds of stories. So we made kind of real life stuff into cards in there. So that's one way to have fun. It'll be more funny once you had a couple beers, probably. But yes.
Since I figure you guys are the ones that have gotten FreeSwitch working the best, how when you push FreeSwitch to the limits, do you know how much calls you can get running on a certain machine, or
how many calls can FreeSwitch handle?
Do you know what the limits of FreeSwitch are?
They, at some point, were congruent with how nice the computer is, but they probably have to reassess that now that I think there's like 80 core machines, which they didn't. When I started writing FreeSwitch, like a 2-core machine was like what the fancy people had, and I only had like a little 1-core one. But I still thought that using more cores was going to be helpful. So, today we normally run on 36-core machines. It depends also if it's like, is it video, is it audio? If it's regular telephony, people easily get into many thousands of calls on a single machine, but it all depends on kind of like, what are each of those calls doing? Like, are they all recording? Are they all broadcasting to YouTube at the same time? So it's hard to get like one magical number, but it tends to be a few hundred per gigahertz of processor as a rule of thumb. So there is upper limits to SIP because our SIP stack used to run on a little embedded handheld machine, and we managed to like retool it to run it on a server. So it's got a little bit of a bottleneck if you start getting into insane numbers of calls, which you don't want to do anyway, because 10,000 calls on one machine isn't good news if it dies. It's like better to have a lot of little machines with a few calls on them if you want to have the least angry customers at the end of the day if something happens to the server. But yeah, it's pretty. That was always our rule of thumb, like maybe say 200 per gigahertz of CPU that you have available. Yes?
We have another question.
Have you ran FreeSwitch on ARM machines? And I think ARM machines, larger ARM machines, can be cheaper than larger ARM.
No, I don't think so. I don't think we've ever tried that. We've been kind of digging in the virtual the last few years because it's easier to set up. We have a couple. My development servers are like rack mount box with like VM server farm thing on it, and we kind of pass through and try and work on that. We've been focusing on trying to make video scalable because that's like an entirely different ballgame because you have like video codecs are pretty intense on the CPU and tuning it right and having lots of calls at the same time on video is a lot trickier than it is on audio. So I remember in the old days I used to give demos here, try and SIP-P attack the machine and show the stuff scrolling by so you could see like how crazy it is to try getting it working. But I think that actually kind of boring for everybody. So I thought it'd be better just to give everyone an overview of what's to come because all these talks are amazing. Make sure you come and see them all because a lot of all your other questions will be answered, especially in the WebRTC roundtable and in the FreeSwitch roundtable. Like you'll have all the guys up here, and you can save up your questions now and get them ready to ask because that's why they're here. So, but I'm happy to keep answering any other questions you guys have now. Yes.
A quick question from Telefono on the feedback on the live feed. He's just looking for confirmation that version 1.10 is available as open source.
Yes, it was dropped last night.
Yeah.
All the regular ways to get it.
So there you are, Telefono.
Yeah. Of course. FreeSwitch is going to remain open source. In fact, we at SignalWire is going to start working on some open source initiatives. We have a GitHub, and we're going to start making some tools and stuff to make life easier to use along with our products, and also contribute, if possible, to some new ideas in telecom that require the larger community and open source collaboration. So we might be working on that, and we'll hear about that during the conference at some point also.
Question in the back in the gray shirt. I'll repeat your question.
The audio recording works great in FreeSwitch, but when we record video, it uses CPU a lot. How to optimize the recording?
His question was about optimizing video CPU usage in FreeSwitch.
About recording?
About recording.
So, when you record video, you're actually using another encoder. And, you know, rule of thumb, I told him that you could maybe have like 200 audio calls on 1 gigahertz of processor. Basically, the 3/4 of the whole processor is needed to have 1 encoder session. And that's like doing it well. If you lower the quality, you can get more out of it. Like 1080p pumped right into an MP4 file is going to by default record as high quality as it can, so the encoder will kick in at the max. And we have some parameters that you can feed to the file. We have file parameters, little curly braces in front of the file name, and you can say like which profile to use in the H.264 encoder. You can lower that. You can lower the frequency of the keyframes that go into there. Because when you're recording video, they like to just pour keyframes into it to make sure it looks amazing when you watch it later. So you can control some of those things. And you can downsize the... you can tune the codec. There's some parameters that we have, like AV has its own config file now, and it's got a bunch of different settings. And we kind of just set default to really high ones, just because people complain otherwise. And tuning it down is a lot better than tuning it up. So just you can look in there, and that should help.
Other questions? All right, big round of applause for Anthony Minessale. Thank you.